So today your assignment is right here. It's called, let me share it with you guys. Here we go. It's called circuit theory simulations. So the first ones were all called hand calculations, and we had to hand calculate the sorry, not the resistance, but the voltage on each side of resistors in series, or the current inside inside parallel circuits. We had to calculate like all that stuff by hand. Now we're going to do it by simulation. So if you look at the packet, we're going to do this one together in class, and this is how you do it, although it's not going to look exactly like this in the online world. In the software in class, it looks something more closer to this, but a little bit more modern. And then you guys will have to do number 2, which is exactly the same as the one we did by hand, so you can actually double check your answers. So you did these by hand already. We're going to do them through simulation now, and then we're going to do this one today as well. All right. We'll save these for tomorrow, the parallel circuits. We'll save those for tomorrow. So let's just do these 3, and I'll start with this one myself, and I might even do the second one for you, and then leaving the third one to do by yourselves. But let's get started. Yeah.
You want us to do it on paper?
No. It's going to be done on the computer. You'll see right now. So here's the assignment right here, and you're doing 1, 2, and 3. And here's the website you have to go to. When you go there, you're going to have to register right here. So I don't know, I think it's right here. For me, I'm already logged in. Once you're logged in, so you'll have to create, so I can log out right now. So what would it look like for you? I guess it would look like this, multisim.com, log in, right? Well, you don't have a login, so go to sign up. And click sign up, and then put in your username, I guess, first name, last name, your role. You're an engineer. What are you? There's your student here somewhere. There's a student right here. So you guys are students, and you can put Whittier High School or something. You can put the school's address if you want to look that up, or put your home address, whatever you want. State, postal zip code. Put your email and your password. Okay, and then create account. Once you do that, you should automatically be logged in. So for me, I'm already logged in. When I click login, I can click here and just log in. Hopefully this works. Last time it said something about my password. There we go. All is good. Looks like I have circuits already saved. So I'm going to create a circuit right here, and that's what you guys will do, is create a circuit. So here we don't need to do any paper. You're not going to need any paper. So I'm going to create a circuit. Remember, our assignment is right here. So I'm going to do number 1. It says shown below is a schematic for a simple series circuit. It is series, and it's very simple. It's only got 2 resistors. Analyze the circuit to determine the total current and the voltage across each of the 2 resistors. To make these measurements, add an ammeter and voltmeters and whatnot. So they're not going to look exactly like this. This is what it should look like. This one reads current. You see this is 0.017 amps, and it's traveling through this little machine, and it tells you the current. Then they take a sensor that senses the voltage on each side of this resistor, and a sensor that measures the voltage on each side of this one. And then that's it. So here we go. Let's get started. 1 second here.
It says like a lies, like up here. We just put something in here. It says required field. I'm creating an account.
On what part?
Let's just create an account.
Oh, this alias. Yeah, that's your name, I guess. So I'm not sure what you can put there. But here we go. Let's get started here. I'm going to build this thing right here. So let's just start with 12 volts and 2 resistors. So let's go here. How do we get a power source? So the first thing you need to know is where we get power. So I click this little guy, and I notice there's DC voltage. There we go. Let's click that, and let's click here. Good. And then we need a resistor. I see one here. So let's click that, and there we go. Resistor. That's all we need. It's a resistor. And we'll need 2 of them. One here. And can I copy this one? I think you can right here. There we go. And I'll rotate this one because I did notice that it is rotated that way, although it doesn't matter because it's electricity. It doesn't care which way you're facing. Next thing I need to do is fix these resistance. See that? That says 1 kilo ohm. That's 1,000 ohms. It should be 220. So I think you can just type it in. Oops. Let me click on it. I think you can type it in right here. There we go. 220, and just push enter, and that did it. And let me click this one. And I think this one was 470. I'll double check in a second. 470, enter. Let me just double check it's 470. And this one's called R1, it already is, and this one's called R2, and it is. R1 and R2. Although it doesn't really matter too much, but if you wanted to, you can probably click that and change that as well right here. Um, Now we need wires, right? Or else electricity is not going to flow. So just, if you look, I'll zoom in here. I'm zooming by scrolling on my mouse. And notice I go here and it turns into a little spool of wire. It looks like a hammer, but that's a spool of wire. And I'm just going to connect this one. And then it's a hand right now. Come on. Move to a wire. There we go. It's a little glitchy, I'll be honest. It doesn't, like sometimes it doesn't want to switch to the wire. I have to wiggle around a couple times. And I'm going to go to this dark line. And by the way, I clicked here. Let me show you. I'm going to push escape. So I'm going to go to that wire again. And notice it's kind of like moving around a lot. And I want to go up now, but it's like, you know. So what you can do is click one time and it'll stop moving around. So now it's like lock that piece in. And then I click again to finish that. But don't forget this ground right here. Do you guys see there's a ground right here? I think it won't work without that. So pay attention to that little piece hanging. That's a ground. And because this is an analog circuit, you need that ground. So it should be under the power stuff right here. I clicked here and I don't see it. Oh, there's a ground right there. I see it. Ground. There we go. It's right here. So click ground. And we'll just click here. And then we need to wire it, of course. So, oh, that is not how I want to move around. There we go. Click the wire and let's wire it to there. And we're done. So if you want to look, that should be the same as this. Oh, it's not. My voltage is 12 volts here. Let's fix that. And I guess we can just push plus right here. Oh, no, let's just type in 12 then. Enter. There we go. 12 volts. All is done now. And it should work. The only thing is for your assignment, it says I need to know the current and the voltages. So watch this. I'm going to click voltage, and it's different. It's not like it used to be where you just drop on your software. You just drop a voltage on each side. You have to click voltage, and then click here, right there. You see, it's like turning into a little echo. So click there. I'm trying to get the voltage on each side of this one. And then I'm going to click this again, but I'm going to go to reference voltage. You see voltage reference? And I'm going to click that on the other side. And I'll show you what that is right now. So let's push play. Oh, do you see how it says 12 volts right here? It's reading 12 volts. And let me show you why. So I'm going to stop this. This is not 12 volts on each side. It's 12 volts here. If we click this guy, what is it referencing to? It's referencing this, which is the positive, to what? Do you guys see this right here? It says its voltage reference is ground. So it's referencing this line to this line, because this is the ground line. Here's the ground, and the ground's always attached to the negative. So it's comparing both sides of the battery, which is 12 volts. I want it to reference this, which is reference 1. That's why I put it there. So I'm going to say, no, reference to reference 1. So you are going to reference to this guy, so I know the voltage on each side of this thing, so I know the voltage of this resistor. So let's push play. Should be less than 12. Yes, it is. There we go. Beautiful. If you want to, you don't need it. I'm sorry, I'm scrolling around too much. If you want to, you can put a voltage on each side of this one too, but it should read 12, right? So if we go here and we click this, and we click this one, and actually I don't even need to click a reference over here, but I could if you want to. Just a good practice to keep doing that reference. So notice this one's called reference 2. I'll move it over here so you can see it a little bit better. That one's called reference 2. So this one I'm going to refer to reference 2. Although it's the same thing as ground, because you can see it leads directly to the ground. So, but just to show you good practice, I'm going to do that. So when we push play, that should read 12 volts, and it does, 12 volts. By the way, if you read negative volts, don't sweat it. It just means you did it backwards. That doesn't really matter that much. So if you would have put the green one here and the reference over here, it would have been backwards, and it would still read 3.826 volts, but it'd be negative. No sweat. All right, let's stop this interaction thing. Oh, this is terrible. All right, and let's do one over here. So let's click the green one, voltage. There we go. And let's get a gray one, voltage reference, right? On the other side, anywhere. It could be anywhere over here. It doesn't really matter. If you want to move it over here, you can. As long as it doesn't go through anything else, you're fine. This one's called reference 3. So I'm going to click this one and say voltage reference should be reference 3. So I want you to refer to this one and tell me what the difference is on this. That's why they call it potential difference, by the way. Voltage is also known as potential difference. It's the pressure difference on each side of this resistor. Because think about it, is electricity going to travel through this? Yes. How does that happen? Well, you need a pressure difference on each side, okay, to make that happen. So let's see. There we go. And Kirchhoff's voltage law says that this plus this should equal 12. And it looks like it does. 3.8, that's almost 4. Plus the 8, that's 12-ish. So this plus this does equal 12. We're not done yet, though, because if we go back, it says, analyze the circuit to determine the total current and the voltage across each of the two resistors. So we forgot the current. I've actually never done current on here, so let's try it out. Current right here. So I guess I just drop it down on here. So this is technically the current coming out of the battery. So let's push play. There we go, 17.391 milliamps. Let me move that out of the way. It's getting a little crowded here. There we go. Now, do I need more? Do I need to put one right here to see how much current's traveling through this guy? No, you do not, because this is a series circuit and it's all the same. Don't believe me? Go ahead and get another one, current, and drop it right here. Wait, I guess you can just go like that. Oh, there we go. Let's put it there, or even right here. And we'll go ahead and do another one right here. And if it makes you feel better, I'm going to copy another one and put it right here. But this one's going to read opposite because it's facing the opposite direction. I don't know how to fix that. But anyway, this opposite means negative. No big deal. See, it's reading negative. So 17.391. 17.391, 17.391, 17.391. This one's negative because it's facing the opposite direction. No big deal. Who cares? I don't know why it's doing that. Maybe just because I'm by the ground or something. But the point is the current's all the same. You don't need to do that. If you have a series circuit, you should already know that the current is the same everywhere on this circuit. It's all one wire. So that's pretty much how to do it. So you would take a screenshot of that. How do you do that? I think there's a button. Just Google how to screenshot on Chromebook if you're on a Chromebook. If you're on a PC like me, I would just click this and type in snipping tool, SNIP. Just push enter. It pops up and say new. And you can just totally do this right here like so.
Can we take a picture to our phone?
And you can take a picture through your phone. That works too, man. Whatever works. So there we go. And then you just send this to me right here. That's a nice little picture of everything in it. I can tell that you've done it right. You got the resistor right. You got the resistor right. You got the voltage, the resistor. You'd put the right resistor. Did you put a current? Yes. Do you have a voltage for this one? Yes. Do you have a voltage for this one? Yes, it is. It's right here, right? That's this one right here. And well, that's it. There's only the two resistors. So pretty much you got everything I need. And I'll just look at that and we're good. I'm going to do one more for you guys and kind of get you started, and I'll let you guys finish it. So I'm going to stop here. I'm going to put number 1 because this is assignment number 1 or homework number 1, problem 1. And how do I get a new one? I don't know. Let's see here. I think we just go to document. Nope. Item. Nope. Maybe I just go here and save. And it's called save, and we'll save it. And maybe we just go here and just pop up a new schematic. I've never gone from one to another before on this software. So let's see. Is there a new file right here? I can't do it. So maybe we have to close this one. Go to my circuits. I'm just going to click Multisim Live right here and go back here. I don't know how else to do that. So I just click Create Circuit, and then I'm going to create a new one. How I did that was I clicked this thing and I went to Multisim Live, which sends me back to the end. I don't see another way to do it, but there probably is. So you can name this one number 2. And then go back to your homework and let's do number 2. And we're doing this one. It's got 3 resistors, 470, 1.2, and 270, and a 9 volt. So let's do that. So we need a power supply. That's DC voltage right here. You're going to be using that one. And then we need a ground because I know it has one. I'm pretty sure, just like the other one did. We're going to need 3 resistors. Resistor, boom, copy right here, boom, and here's the copy button right here, there, and I'm going to rotate this one because I do think it is like that. Oh no, it's down here on the bottom. It doesn't really matter in the end, truthfully. There we go. And it was right here, and these two right here. Let me see if I can put them on the same line just so it's pretty. Nope, what? I'm still moving that one. There we go. And now let's wire this up. Let's click here. Let's click here. Click here. Come out a little bit. I'm going to click here. Oops, I missed it. That's okay. It doesn't need to be straight line. Electricity travels all the same. And then here we go. Oh, there we go. And then here we go. Click this one up to here somewhere. It doesn't matter where. As long as it goes directly to that negative. As long as this can go directly to the negative without traveling something, we're good. And then we got to change these. I forgot what they were already. 470 and 1.2. So this one is 470. And this one is, and you could always just type in 1.2 and then type a K there, and then enter, and then you get a 1.2K. And this one is the 270. So just type in 270, enter. And we're already done setting this one up. And once again, as a reminder, you need a voltage here, a voltage here, a voltage here, and one current is fine because this is in series. All the current travels through this one, travels through this one, travels down, travels through this one, and comes back. So you only need the one current right here, and then you'll need a few voltages, 3. You click voltage, this side, then reference voltage, this side, then click this guy right here, and whoa, this is not here. Where did this go? I'm missing my menu over here. Let's see. There we go. I had to click this little wheel right here. So if you don't see that, click that little wheel. And I'm going to click this voltage, which I did, and I'm going to say reference to RF1. So reference to this guy. So this one references to that and tells the difference right here. Then do that again. Here. Voltage reference on the other side. Doesn't matter where. You could have put it down here, as long as you don't put it on the other side. So let me show you that again. I'm going to do a voltage reference, so I know the difference between here and here. So I can put it here, I can put it here, I can put it here. I could even put it here and here. It would be the same thing all the way through. It's all the same thing. Just don't put it on the other side of this thing. Don't put it on the other side of that resistor. Then you've done it wrong. So as long as you're on the other side, you're good. And then voltage, here we go. And reference right here. And don't forget to click these. This one needs a reference to this one. So we go over here and say reference to 2. Click this one, and it needs a reference to 3. And then, oh, and I forgot to change the voltage right here. I think it was 6 volts. Yes, no, it's 9 volts. So just change this to 9 volts. Push enter, and we're all good. Voltage is correct. Resistances are all correct. I have voltages everywhere. Push play, and take a screenshot of this. If they're a little too close together, please move them around. Just push stop and move this right here. You could even move this right. No, come on, not face the correct direction. Why are you going that way? I don't know how to face this the correct direction. I'm going to get a negative value if I do that. Oh well. It doesn't really matter if it's a negative value. I'm not sweating that. So here we go. Take a screenshot of that. It's got the voltage here, the voltage here, and the voltage here. There it is. If you add them all up, they should equal 9. I think they do. That's like 2. That's like 7, because 5 plus 2, that's 7. And then another 1.2, that's going to be 8 point something. But with those leftovers of those, it becomes 9. You can add them up. It's probably really exact on this because it's carrying so many digits. And that's it, folks. So just do number 1, 2, and 3. Submit all 3 pictures, and you're good.